Assalamu alaikum, dear student. This is Muhammad Mahawala, lecturer in chemistry, English medium leadership, Rajagutra Model College. Today I would like to deliver a very important lecture on organic chemistry. This is my 7th lecture on the chapter. In my lecture, for the first time, I would like to say something about alkyne. You know very well any compound that basically contain a triple bond having general formula CnH2SN, and we include it into the series of alkyne. So the preparation process of alkyne, there are a number of processes to prepare alkyne. Among all the process I have here basically chosen 3 processes. The first process is hydrolysis of calcium carbide. If you hydrolyze the calcium carbide, this is basically the structural formula of calcium carbide. If you hydrolyze this type of calcium carbide, then you will be able to get the first member of alkyne, ethyne, in addition with calcium hydroxide. So this is basically the way to prepare ethyne. Okay. Now the second process, dehydrohalonation of vicinal dihalide. Now the second process, dehydrohalonation of vicinal dihalide. What is vicinal dihalide? If in any halide 2 halogen atoms are attached with the 2 adjacent carbon, this type of halides are basically called vicinal dihalide. When this type of halides react in presence of alcoholic potassium hydroxide, then 2 HBr molecule will be eliminated from these 2 adjacent carbon. By this way, they produce this type of compound, I mean to say alkyne, in addition with potassium bromide and water. Now the third process, dehydrohalonation of geminal dihalide. Okay, the halide where both the halogen atom is attached with the same carbon. Both the halogen atom in that case must be present with the same carbon. This type of halogen is basically called dihalides, geminal dihalides. Okay, this type of halides, if added with potassium hydroxide that is present in ethanol, then HBr will be eliminated from 2 adjacent carbon. In that case, by this way they are produced an alkyne in addition with calcium, potassium bromide and water molecule. So these are basically the process. The first process is hydrolysis of calcium carbide, second process is dehydrohalonation of vicinal dihalide, and third process is dehydrohalonation of geminal dihalides. By this way, this is possible to produce alkyne. Now I'd like to say something about the acidic nature of ethyne. You know very well ethyne is acidic in nature. It has slightly acidic character. Okay, this is basically due to the presence of sp hybridization of each of the carbon atom. In case of ethyne, both the carbon atom are sp hybridized. Okay, we know very well. In case of sp3 hybridization, the S character is 25%. In case of sp2 hybridization, S character is 33%. In case of sp hybridization, the S character is 50%. The greater the S character, the greater the bonding electron will be held tightly. Okay, so as both of them are sp hybridized and both of the carbon has 50% S character, so the carbon-carbon triple bond here that is present will be held strongly, will be held tightly. That's why this carbon will be little bit electronegative. Okay, as this carbon will become electronegative, by this way carbon hydrogen bonded electron will be shifted towards this carbon and carbon hydrogen bond will be weaker. Okay, by this way this will be more easy in that case to release this hydrogen atom as proton from this compound, and due to this reason basically the ethyne molecule 2 hydrogen atom are little bit acidic and they can be released from ethyne molecule as proton. As they as ethyne molecule can have the capability to release protons, so I can say ethyne molecule are acidic in nature. This is basically the reason for which reason this proton or hydrogen can be replaced, and substitution reaction in case of alkyne is possible due to the acidic nature of alkyne that basically contain hydrogen atom with this carbon. Okay, this type of alkyne normally acidic in nature. For example, ethyne, for example, propane. Okay, like this alkyne. If it wants to be acidic in nature, with this carbon there must have a proton. If there is no proton with the 2 hydrogen atom, if it is a methyl group, in that case this will not be acidic in nature. Okay, so the carbon must contain a hydrogen if it wants to show acidic nature. Okay, So dear student, now the reaction of alkyne, there are number of reactions that can be carried out by alkyne. For the first time, addition of hydrogen. Addition of hydrogen is a very important reaction to find out alkane or alkene from alkyne. In that case, you have to supply here hydrogen molecule in addition with nickel and 200 degrees Celsius temperature. In case of the preparation of alkane from alkyne, you have to supply here 2 molecules of hydrogen. Okay, if you supply 2 molecules of hydrogen, then these alkyne will be converted to alkane. But if you use here barium sulfate added to it palladium, okay, barium sulfate added with palladium, this is called a poison. Okay, and another name of this palladium plus barium sulfate is called Lindlar catalyst also. If Lindlar catalyst is used here, rather than added 2 molecules of hydrogen in this compound, they are add only 1 molecules of hydrogen. By this way, you will be able to produce here only alkene rather than production of alkane. So if you want to prepare alkene from alkyne, you have to use Lindlar catalyst. In that case, 1 molecules of hydrogen will be added in the carbon-carbon triple bond portion. By this way, you will be able to produce a alkene. Now the reaction with water, this is very important reaction, and I have already discussed this in one of my lecture. This is also water addition reaction too. In that case, when it react with water react with ethine in presence of a 2% mercury sulfate and 20% sulfuric acid at 60 degrees temperature, then water will be added in this compound through the breakdown of a pi bond, and this type of product will be produced. In that case, the name of this product is enol compound. Okay, both in and all functional group present in this compound, and that's why this type of compound is called enol compound. Okay, through the rearrangement of this group, through the rearrangement of this compound, they are produced ethanol. Okay, after the rearrangement of this compound, it will be converted to ethanol. So by this way, from ethyl, there is a chance to produce ethanol. At the same time, if water is added in presence of same catalyst with propane, for example propane, in that case you will be able to find out basically ketone. So if you want to prepare aldehyde, you have to add here, you must have to add here alkyne, ethine, and if you want to rest of the ketone, okay, except ethanol, then in that case, if you want to prepare propanone, I mean to say, if you want to prepare propanone, then you have to add here propane. Okay, now ozonolysis reaction has already discussed in previous lectures, so I don't explain it now. Aromatization is really very important. This is basically the process where ethane can be converted to benzene. This is really very important for us. If you want to prepare benzene from ethane, you must have to carry out this reaction. This reaction must be happen in presence of hot iron tube. Okay, hot iron tube is really very necessary in that case, and this reaction must be carried out in presence of 400 degrees Celsius temperature. So at 400 degrees Celsius temperature, ethane will be converted to benzene. So these are basically the chemical reaction. So the first reaction is addition of hydrogen, second reaction is reaction of water, and third ozonolysis, and fourth aromatization. So dear student, now identification of alkyne. There are number of processes to identify alkyne. The first process is bromine test, second one is Bayer test, and third one is formation of copper and silver acetylides. Okay, in bromine test, if you take the solution of this compound in a test tube, and then if you add here red colored bromine solution, then after the formation of the product, when the product start to produce, then the red colored will be disappear in the solution. Okay, the decolorization of the red colored bromine in the solution after the formation of the product, and it confirms basically the presence of ethine or alkyne in the solution of the test tube. So by this way, this is possible to confirm or identify alkyne. Now the second process is Bayer test. Okay, when you take the solution of this compound in a test tube, Okay, and if you add here potassium permanganate dropwise, you know very well the color of potassium permanganate is pink colored. Okay, so pink colored potassium permanganate, when you add the test tube which contain this compound, then when the product will be started to produce, then you will see that the pink color of the potassium permanganate will be started to disappear. So the decolorization of the pink color solution of the potassium permanganate confirm the presence of alkyne in that test tube. Now the formation of copper and silver acetylates. I have already said for a number of times, any alkyne that basically contain hydrogen atom with itself, it will be released here as proton, and this type of alkyne can be act as a acid, okay, or they have acid character. So only for this type of compound this identification test is possible. Okay, when ethane, for example ethane, when ammonium hydroxide added silver nitrate, when added with the solution of ethyl, then basically there happen a substitution reaction. Each of hydrogen atom are replaced by the silver atom. Okay, by the silver atom. By this way they produce silver acetylates white precipitation. The name of the compound is silver acetylate, and white precipitation of this compound will be appeared in this solution. Then by the presence of white precipitation of the silver acetylate, you will be confirmed of the presence of alkyne. At the same time, if you add it here, thus in this solution, ammonium hydroxide added cuprous chloride, then they produce copper acetylates, red colored precipitation. The presence of red colored precipitation of copper acetylate will confirm the presence of alkyne in that solution. So by using these three processes, bromine test, Bayer test, formation of copper and silver acetylates test, you will be sure of the presence of alkyne. At the same time, if you want to analyze, if you want to identify both alkene and alkyne, if you want to identify either this compound is alkene or alkyne, okay, if you want to differentiate between alkene and alkyne, you have to identify this process. Okay, both alkene and alkyne, both of them are unsaturated, so both of them will undergo bromine test and Bayer test. Both of them give bromine test and Bayer test. Both alkene and alkyne will give bromine test and Bayer test, but alkene doesn't give this reaction because alkene are not acidic in nature. Okay, due to the acidic nature of alkyne, this type of reaction is possible, but alkene are not acidic in nature. That's why alkene doesn't give this type of reaction. Okay, so to differentiate between alkene and alkyne, this reaction is really very important. Both of them reaction, bromine test and Bayer test, is possible in case of alkene, but this reaction is not possible in case of alkene. This is basically the way to differentiate alkene and alkyne. Now I would like to say something about 1-butane and 2-butane. How can you differentiate 1-butane and 2-butane? Look at 1-butane. There is a hydrogen atom. Okay, there is a hydrogen atom present with this carbon. But in case of 2-butane, there are no hydrogen atom attached with the carbon. So as they does not contain any hydrogen atom with the carbon, so there has no chance to happen this type of reaction. Okay, so by using this type of reaction, there is no chance to identify this compound, but this compound is possible to identify by this way. So by this way you can differentiate, you can differentiate 1-butane and 2-butane by using this test. Okay, so I hope you understand. So dear student, now alkene, preparation of alkene, you can easily prepare alkene from alcohol and sulfuric acid. Here I have taken ethanol. The reaction of ethanol with sulfuric acid at 100 degrees Celsius temperature, they produce ethyl hydrogen sulfate. When you heated this ethyl hydrogen sulfate at 165 degrees Celsius temperature, then sulfuric acid molecule will be eliminated from this compound and they produce alkene, for example ethene here. Okay, now from alkyl halide, this is also possible to prepare ethene. In that case you must have to add here alcoholic potassium hydroxide. This is very mandatory matter. Okay, if you add here aqueous potassium hydroxide, in that case the product will be alcohol. Okay, if you use your alcoholic potassium hydroxide, then the product will be alkene. So the addition of alcoholic potassium hydroxide you must have to confirm in that case. So by this way you will be easily able to produce alkane. Now the third process, by using Lindlar catalyst. I have already told it. What is Lindlar catalyst? This is a poisonous catalyst. This is basically the catalyst of barium sulfate added with palladium. This type of poisonous catalyst, when you use, then only in that case only a single number of hydrogen molecule will be added to this carbon-carbon triple bond portion, and by this way you will get alkene from alkyne. So these are basically the process. So dear student, now identification of alkene, basically these are bromine test, Bayer test. These are basically the test of unsaturation. Okay, these are applicable both in case of alkene and in case of alkyne too. I have already discussed in case of alkyne. Now I would like to discuss in case of alkene. So in case of alkene, if you take a solution of this compound in a test tube, and if you add bromine red colored solution dropwise in this solution, then the red colored solution will be disappear with the formation of the product. The name of the product is 1,2-dibromoethane, which one is colorless. So the decolorization of the bromine confirm the presence of this compound. At the same time, Bayer test, if you this Bayer test is also oxidation reaction of alkene. This is also a oxidation reaction. Okay, and here you have used oxidizing agent potassium permanganate, okay, which supplied nascent oxygen. You have already seen in the board. The color of potassium permanganate is basically pink colored. Okay, the color of potassium permanganate is basically pink colored solution. When you add this with this compound, then the pink colored solution, the pink colored will be disappears with the production of 1,2-ethane 1,2-diol colorless compound. The decolorization of the pink color potassium permanganate confirm the presence of ethene in this compound. So both the bromine test and Bayer test are applicable in case of test of unsaturation. So this is applicable in case of both alkene and alkyne. So now isolation of alkane, alkene, alkyne and carbon dioxide from any mixture. Okay, if there is a mixture where alkane, alkene, alkyne and carbon dioxide are mixed each with other, from this mixture what is basically the way to isolate each of the element. Okay, for the first time the mixture is first through the solution of potassium hydroxide, thus carbon dioxide will be absorbed with the formation of potassium carbonate. The remaining gases pass over without any reaction. Then the carbon dioxide will be recovered by reacting it with hydrochloric acid. Okay, and potassium hydroxide is, when the mixture is passed through the potassium hydroxide, then potassium hydroxide absorbs this carbon dioxide to produce potassium carbonate. Okay, then as potassium carbonate, carbon dioxide will be absorbed, and then this potassium carbonate will react with hydrochloric acid, and with the addition of hydrochloric acid, carbon dioxide will be produced for again time, and by this way carbon dioxide will be recovered and separated. Now the second step, the gas mixture passes through the ammonia and cuprous chloride solution, then ethyne acetylene is absorbed with the formation of copper acetylite red colored precipitation. Okay, when the mixture is passed through the solution of ammoniacal cuprous chloride, they are produced copper acetylite red colored precipitation. Through this process acetylene is absorbed in that case. Okay, and then HCl acid is added in that with this compound, and they produce acetylene, at the same time cuprous chloride. Okay, by this way acetylene gas is recovered and eliminated and separated from the mixture. Now the third step, the rest of the part where ethene and ethane is present. Okay, alkane in this mixture, then the mixture is added with sulfuric acid, then ethene is absorbed as ethyl hydrogen sulfate. Okay, when the mixture is added with sulfuric acid, then the ethene from the mixture will react with the sulfuric acid, and they produce at 100 degrees Celsius temperature, and they have produced ethyl hydrogen sulfate. So by this way, ethene molecule is absorbed here as ethyl hydrogen sulfate. While after the formation of this product, after the absorption, then you have to apply here heat 180 degrees Celsius temperature, then ethyl hydrogen sulfate will be converted to ethene, and in addition with sulfuric acid. So by this way, ethene is also recovered. So to absorb carbon dioxide, they are used potassium hydroxide, and potassium carbonate is produced, and by using hydrochloric acid, carbon dioxide is recovered. At the same time, to absorb acetylene or ethane, they have used ammoniacal cuprous chloride, and by this way they have produced this precipitation, and later they are use hydrochloric acid to recover ethane for again time. So by this way carbon dioxide is separated, by this way ethane is separated, and to separate ethane, here basically use sulfuric acid by this way, and by this way ethene is also separated. So these are the three process. By using three process, from in first process carbon dioxide is eliminated, second process ethane is eliminated, and last one process ethene is eliminated. So our rest of the part that is present in the mixture is ethane. So by this way both by this way alkane, alkene, alkyne, carbon dioxide, I mean to say ethane, carbon dioxide, all the element, all the molecule get separated from one another. So this is basically the way to isolate all the component. So dear student, in this lecture we are able to know about, for the first time, about alkyne details. We have studied alkyne preparation process of alkyne, identification process of alkyne, chemical reaction of alkyne. Okay, details we are able to know about alkyne. Later alkene, what are basically the preparation process of alkene, identification process of alkene. There are a number of reactions that can be possible by alkene. The reaction of alkene is basically discussed in previous lecture. That's why I do not I do not give any lecture about the chemical reaction of alkene. Okay, later I have tried my best to solve the process, the isolation of alkane, alkyne, and carbon dioxide in this lecture. So thank you.